Hey scholars, my name's Brendan and I'm going to be working with you today on the dot product and vectors, particularly in physics application with force and displacement. What we're going to want to find is, given the force of an object, force is equal to negative 20 in the j direction, and I've drawn that out here. I'm going to want to find the component of F parallel to V, and then the V vector is the displacement vector, and that is shown right here, and the component of F perpendicular to V as well, and I've drawn that in with just a little dotted line right there. And then finally the work, W, done by the force F through the displacement V. So the first step that we're going to want to find is the unit vector of V. So the unit of V, now it's easiest for me to think of this like a triangle. I have the hypotenuse, and I have a length of 5 and a length of 1. So I can tell pretty simply 5 squared plus 1 squared. The square root of all of that is going to be the square root of 26. So then if I divide both of these by the square root of 26, I should end up with the unit vector. So in this case, the unit vector is going to be 5 over square root of 26 minus 1 over the square root of 26. And I'll add I and j to make it clear that these are vectors that we're talking about. So what I just found right here, this is the unit vector parallel to v. Now, I'm later going to need the unit vector perpendicular to v, so let's just get that out of the way now. We know that the two of them dotted to each other will equal 0, so I'm just going to put in the reciprocals, or the opposites rather. So the unit vector of parallel to v will equal 1 over the square root of 26 minus 5 over the square root of 26, and then I j vectors. And so now we have the unit vector going in this direction and the unit vector going in this direction. So now that we have the unit vectors, the next step is going to be to assign magnitude to them. So let's start with F parallel. Now we know that F parallel is going to equal the vector F dot vector V all over the magnitude of vector F. So in this case, that's going to be vector F dot vector V will end up with just 20, and then in fact that will be 20 over the magnitude of vector F, which is also 20. And so that will be negative 20 over 20, which equals 1. In fact, this will be equal to the unit vector. We can just write F parallel equals 5 over the square root of 26 I minus 1 over the square root of 26 j. And that brings us to the parallel vector, which will be slightly more complicated. So we can see that vector F is going to be made up of its component parts, that is to say it will be equal to vector F parallel plus vector F perpendicular to vector V. Now that we can write out as negative 20j equals 5 over the square root of 26 I plus, let's say, ni minus 1 over the square root of 26j, perhaps plus mj. Now moving down just so we have a little bit more space, we can see that we need to cancel out the I, so in this case n is going to be equal to minus 5 over the square root of 26. So I'll just write this elsewhere. Vector f parallel is equal to minus 5 over the square root of 26 I plus, and this is when it takes a little bit of math whiz mathematics. We need to add something to negative 1 over the square root of 26 to get us to negative 20. So we can see that it's going to be a subtraction. It will be, so as a matter of fact, that will be equal to negative 19.804j. So that will be f perpendicular. So now we have f parallel and f perpendicular, and the next step is going to be the work W done by force F through displacement V. And so we know that W equals the magnitude of F parallel times dot vector V, that is to say displacement. So we have F parallel, and in this case the magnitude is going to, rather it's actually the magnitude of F parallel times the magnitude of vector V, so that's actually just a bit simpler. That's going to be, that will be the square root of 26, because as we can see, the magnitude of vector F parallel is equal to 1, and as we can see here, the magnitude of vector V is going to be the square root of 26. So going down where we have space, we can see that that will be equal to 1 times the square root of 26, which is equal to the square root of 26. And that is going to be the quantity of work that is completed. Generally, that's measured in joules. So I hope you've learned a little bit more about vectors and the dot product from this, and I look forward to educating you even further in the future.